Okay, question 9. Ethane 1,2-diol can be made from ethene. Flowchart of an industrial process to produce ethane 1,2-diol is shown. Okay, so we've got our system here. Industrial processes are designed to maximize profit. Using the flowchart suggests 2 ways to maximize profit in this industrial process. I have just lifted in the mark scheme for this one because it's not asking you to give a new way. It's asking you to recognize what's here. So that kind of threw me, to be honest. So that's why I brought in the mark scheme for that one. So here's a recycling of gases. That's useful. Okay, you'll notice that we also have multiple points where you've got a catalyst running, and that will help to reduce costs, okay, which will maximize profit. We've got liquid byproducts down here, so the sale of these would be reasonable. And that was the ones that I'd picked up, but just to be clear what the other ones were they had. So they had the recycling of the waste gases, they've got the catalyst, and they've got selling or using byproducts. And then the other ones, which when I looked at the mark scheme I was like, yeah, okay, absolutely, I should have seen those ones. This temperature is really low, so that's a low cost thing, which is good. Okay, that's your low temperature. And then because of that, they've got this low or reduced energy requirements. I'm not entirely sure if that's, I would have linked that to the catalyst, but I think that's fair enough to have as a separate point. And then they've also got this one about the feedstocks in here. The feedstocks in here are ethene and oxygen. And, well, certainly oxygen inexpensive because you can just extract it from the air. So that's why that's there. Oh, and also water down here. So, yeah, not looking for new things, looking for what's there. Name the process used in separator 2 to separate ethane 1,2-diol from the larger liquid byproducts. So if you're told that you have products which are liquids and you're trying to separate them, I'm expecting distillation. I actually would really expect fractional distillation, but that wasn't actually required in the mark scheme. Distillation was accepted. Okay, explain fully why ethane 1,2-diol is more viscous, I almost said vicious, than propan 1-ol. Okay, so what we have here is ethane 1,2-diol. Okay, and we then have propan 1-ol. Okay, so viscosity is linked to how many connections and how strong those connections are that you make between other molecules. Now in propan 1-ol, there's our strongest interaction we can get. We can get a hydrogen bond between that hydroxyl and other hydroxyls. Ethane 1,2-diol, even though it's a smaller molecule, has 2 points at which it will bond. So really what we're looking at here is the bonding opportunities, and there are a greater number of bonding opportunities to different molecules, intermolecular ones, in the ethane 1,2-diol than in propan 1-ol. 4C, draw a structural formula for a diol that contains 3 carbon atoms. That's basically anything that's right. So 3 carbon atoms, I could just go for 3 carbon atoms and stick hydroxyl groups on 2 of them. Or I could put them on the same one and either have this as this way round, or I could have that as the 3. I could even go to a cyclo, stick an OH on one of them, on another one, or I could put them on 2 of them. You know, it says a diol that contains 3 carbon atoms, so you've got lots of choices, just as long as you've got 3 carbon atoms and all the right number of hydrogens. And obviously in a final exam you put them all in. Okay. D, ethane 1,2-diol has been found to be harmful to animals. Treatment for the affected animals involves using a 20% ethanol solution. The 20% ethanol solution is prepared by accurately measuring 20 centimeters cubed of ethanol, then making up to exactly 100 centimeters cubed with water. Describe the procedure which should be used to prepare the 100 centimeters cubed of the ethanol. Okay, so it's a liquid. So to get an accurate one, you're going to take a pipette, 20 centimeters cubed of your ethanol into a volumetric flask, and then you're going to make up to the graduation mark. So make up to graduation with distilled water. Okay. And that's it. Okay, an affected animal must be treated with, sorry, I'll spin down, 9 doses of 20% ethanol solution. Each dose contains 5 centimetres cubed of the ethanol solution for every kilogram body mass of the animal. Calculate the total volume in centimetres cubed of the 20% ethanol solution needed to treat a 3.5 kilogram animal. Okay, right, so we have a 3.5 kilogram animal, and that needs to have 5 centimetres cubed per kilogram, so times that by 5. So I need 17.5 per dose. Okay, and I need 9 doses. So I need 157.5 centimetres cubed for my final one. It's only worth 1 mark, you can see why. Okay, spin it down a little bit here. Ethan 1,2-diol is harmful because it's oxidized in the body to form glycolytic acid. And a little picture of. Draw a structural formula for another possible product of oxidation of ethan 1,2-diol. Okay, so let's bring back up the diol. Okay. Here's my OH. Here's my OH. Right. Oxidation. Well, basically, we could get oxidation of this one to an aldehyde rather than to the acid. So I could just change that to this. Okay, I could also do both of them to aldehyde, so just have both ends at C double bond O bond H, or I could do both of them to acid, would also be reasonable. So I could have, let's say, my double aldehyde, oh sorry, H, double bond O, sorry, making a mess of this one, or I could have my double acid, or I could have a combination of acid and aldehyde. Whichever. Yeah, there's quite a few. It just says E, structural formula. Not asking you to name it, just give a picture. Glycolic acid can be neutralized by sodium hydroxide to form sodium glycolate. Give a formula for sodium glycolate. Okay, so what we have here is this hydrogen would be removed and it would attach to sodium. Okay, that would be an O minus to Na plus. But it's asking for a molecular formula, not a structural formula. So let's do some counting. Carbons, I have 1, 2. Hydrogens, I have 1, 2. Not this one, this one's gone. 3. And oxygens, I have 2. And, oh sorry, not 2, 3. 1, 2, 3. And a sodium. Okay, if you'd written it, so this is just a straight molecular formula, you could have written it out as the kind of structure, which would be the OH, CH2, and then COO minus Na plus, but that's the one I was expecting. Okay, I realise you have no idea about this, but this is the last one of all of the past papers. I am so glad. I just now need to format them all and upload them all, which will probably take me hours, but I really hope they're helpful.